No, actually, no one said that. Actually, you. Actually, no one said that.
Hi, good morning, everyone. Nice to see you all here today. Before we get started, a couple of announcements, and maybe we'll start with the usual. There's obviously lots of events that can be stressful or bad news. Lots of that kind of stuff going on in the world. So why don't we start with what would you like to share? What kind of good news would you like to share? Does anybody have anything exciting, interesting, funny, or good news that they'd like to share with the class? Surely something has happened in the last week among the 100 and some of you that's kind of a happy piece of news. Don't all jump at once. Did everybody have a bad week, or is this just one of those days? I'm sure I could make some stuff up. Is anybody celebrating a birthday? Anybody know anybody celebrating a birthday? Has anybody you're celebrating a birthday?
Celebrating a birthday. I know someone who.
You know someone who is. Okay, well, that's, at least 1 degree of separation. Anybody acquire a new plant? Anybody's cat doing well? I've been without a cat for over a year now because our cat was sick 2 years ago. We had to put her to sleep. And last year we did not have a cat, but I have now identified on the London Humane Society the cat that I would like to target to adopt. So we're going to see if this works out. He's a 1-year-old cat, and yes.
Finally found a dress for the end of year formal I'm going to.
End of year formal you're going to. So not only are you going, which is good news in and of itself, but you'll have a dress to wear, which is even better. Well, congratulations. Good job. Good job finding a dress. Other sort of comparable types of good news. Who's got something else to share that's around there? Otherwise, I'll keep talking about the cat that I might adopt. Yeah.
Yesterday, my landlord came and they got our oven fixed.
You got your oven fixed. Your landlord finally showed up, did the right thing. How long were you ovenless?
I've been working for, I think, like a month. We finally just got like, hey,
month?
you come in, he'll say night with this. So we sent someone in to go check it out.
Yeah. How many of you find the landlords in London to be substandard? Don't all raise your hand. Yeah, I feel like an hour, a month is too long to live ovenless. I don't know what I would do if I didn't have an oven. Like I would, if as a homeowner, I would buy a new oven or I would repair it. But if somebody's responsible for this, that is to say the landlord who is the actual homeowner, well, congratulations getting your oven fixed. What are you going to do with your new oven?
Bake a cake.
Okay, bake a cake. I thought you were going to say continue to not bake anything in it. But yeah, bake a cake. Great idea. Any other good news?
I got awarded a scholarship for my master's degree.
A scholarship, that's actually that's some exciting good news. Fantastic. What's the master's degree?
It's in gender studies here.
Here at Western? Well, congratulations. So you're going and you got a scholarship. Good for you. Well done. You had somebody held their hand up here. You baked a cake yesterday. So what kind of cake?
It was kind of like a funfetti cake.
A funfetti cake. Passed your exam, so you got a cake. That's a good way to celebrate. So cakes, potential cakes, scholarships, all sorts of good news. Anything else before we get started? A little bit of good news on our part. You should have your midterm grades later today. I just need to review that everything's there. One caveat, if you took your midterm exam as the makeup exam and took it with accommodations, those were just delivered, so those haven't been marked yet. But I will release the rest of them at some point later today. I just need to upload and make sure everything matches. So I do apologize you had to wait an extra week or two, but they should all be there. And as always, if you have questions, contact me or one of the TAs. If you do want to review your exam, keep in mind, and this is, I think, on the course outline, TAs can review the exam with you, and you should review your exam with the TA that marked your exam. They can't change the grade for you. So if there is a grading error, so if something was added up incorrectly, that's obviously something that's going to be corrected. But if you feel as if one of the written exam questions wasn't graded in a way that, or you didn't understand, they can certainly talk you through that, but they won't change the grade with you there. They would consult with me afterwards if there was something like that. But generally speaking, once the grades are released, we don't change them. But you do have, and this is true not just for my class, this is true for all classes. You have the right to review your exam and written work at any time. It's sometimes complicated to do so in a large class, but you always have the opportunity to review an exam or to review any written work that you've had in this class, or, like I said, any other class that you have at Western. So those will be available today. Let's get started with today's lecture. In terms of content, let me just slide the floating meeting controls. In terms of the content for today's class, we should be able to finish up roughly around 12 o'clock. I'll try to make it through some of this stuff. There aren't any long delays here. We'll do a little bit of review, and that should get you time to start for the quiz today, which is available at 12:30. So, any questions before we start? All right, I already made these announcements. Quiz 3 today starts at 12:30. It'll be online, same format, same style as everything else. You'll see all the questions. You'll be able to review them. You've got all day to complete it as long as it's submitted by 12:30 a.m., meaning 12:30 a.m. tomorrow morning. So you've got 12 hours to complete the quiz. I usually try to get the recording for this lecture posted on the OWL site, on the Brightspace page, as soon as it's available. So if you want to wait until this is available, that's fine too, but that should be around 12:30. Midterm exams are just about ready to release. That should be released later today. I had one other announcement I made on Brightspace today. I do have office hours from 2 to 3 every week. I will be on Zoom only today because I have a meeting off campus and I won't have time to get back to my office. So if you are planning to attend my office hours, it'll just be on Zoom today. Okay, so one of the questions, actually 2 people mentioned they would like to have just a little bit more discussion of the inclusion fallacy and how it relates to the feature coverage model and the similarity coverage model that we talked about. So I have 3 slides that we'll go over, and that'll sort of be some review, and then we'll get started with deductive logic and causal reasoning. So the inclusion fallacy has to do with what the correct answer should be. What should people say when they endorse one of these 2? And what we suggested is, given these 2 arguments, all robins have sesamoid bones, therefore all birds have sesamoid bones, versus all robins have sesamoid bones, therefore all ostriches have sesamoid bones, that most people, and it seemed like it was about split 50-50 when we did the test here in class, that the majority of people, a small majority of people, prefer the first argument. That could be a problem in the sense that it is a fallacy. It logically shouldn't be the stronger argument. This poses a problem for the similarity coverage model, but it doesn't pose a problem for the feature coverage model. The feature coverage model assumes that argument strength is based on the number of shared features. So I'll go through those 2 examples. It's a fallacy because people, when they endorse this option as being the preferred or the better or the stronger argument, are relying on featural similarity, that robins share a lot of features with all birds in general. And the birds that come to mind, and this would be an availability heuristic, when you think of birds, you think of birds that are kind of like robins. In terms of category inclusion and a sort of a hierarchical structure or a taxonomic structure, it's likelier that robins would have things in common with ostriches, a subset of all birds, than they would with all of the birds. And of course, remember, all birds also includes all ostriches. And so this, if you're relying solely on category membership and taxonomic membership, should be the stronger argument. That's what the similarity coverage model would bring. And so I had 2 slides which tried to make that case. And this explained how the 2 different models work. So Osterson's model suggests that argument strength or inductions are based on category membership, and they're based on 2 things: the degree of similarity overlap, however you want to calculate similarity, between the premise and the conclusion categories, and the degree to which all of the predicates mentioned cover the entire category that subsumes all of the things that you're reasoning about. So if you're talking about birds, it would be all the birds. And so it predicts things like birds and robins versus, birds and sparrows versus birds, sparrows and ostriches, or horses and cows versus horses and dolphins, because they're more similar. And this coverage effect has to do with diversity. So we talked about things like hippos and hamsters being a better case because it covers more of the category, or horses and dolphins inferring something to all mammals covers more of the category. Feature coverage model makes exactly the same predictions for the same reason. Those things share more features. Where they diverge is on the inclusion fallacy. So the feature coverage model makes the assumption that rather than calculating similarity and then thinking about coverage separately, you would determine how many features are shared when you're making an induction. So when you're thinking about making an argument or trying to project a new property to something, that you would rely on featural comparisons. And in the case of horses and cows, they share a lot of features. Robins and birds and share a lot of features. Robins and sparrows share a lot of features. So both of these models are able to account for things like typicality and diversity effects. Maybe there's some disagreement on the actual mechanism. The similarity coverage model also assumes that you have to, and this is one of the questions in the foggiest concept, what degree is taxonomic knowledge necessary? The similarity coverage model assumes that you've represented something about the taxonomic structure. In other words, that hierarchical structure of categories and concepts, that you know what birds are, and that you know that sparrows and ostriches are birds, and you know the relationship of these different kinds of concepts. That's where the similarity comes from, and that's where your knowledge of coverage comes from. Sloman's model, the feature coverage model, suggests that it isn't necessary to have that relationship or that knowledge of taxonomic structure as long as you're familiar with the features. So it's more of a family resemblance feature model. And so it's able to account for things like this inclusion fallacy because it's able to account for the reliance on featural similarity rather than conceptual similarity. Does that seem clearer than it did last week? Or at least no more unclear than it was last week? But I do feel like last week I was starting to run out of gas towards the end of the lecture and was maybe rushing through this a little quicker than I intended to. So if this seems okay, we can move on. Okay, I don't recall exactly how many questions on the quiz are on these, but there's always one or two. And there will certainly be questions on the final exam about both of these models. You can, I wouldn't say you can guarantee, but you could probably highly predict that a question like this would show up. Which of the two models is able to predict how people behave with the inclusion fallacy? Or maybe I would list a set of statements that aligns with the inclusion fallacy. A question that I've often asked as a long answer question is one in which I ask you to say, what do people normally say? And is this a fallacy and why? And then also, which model of the two that we discussed would better predict people's behavior? So knowing the relationship, and I do talk about this in the text as well, knowing the relationship between these two models and something like this particular fallacy would be important. Does that seem good? Okay. All right. Back to the slide that we started last week with, which is what is reasoning? Reasoning is kind of a form of thinking where you use what you know about the world to be able to discover something new, to do something new by thinking about it. And we discuss lots of different ways that we can reason: causal reasoning, inferential, inductive reasoning, deductive reasoning, a lot of these kinds of things. So reasoning and logic is going beyond the given information in order to comprehend the situation. Does this seem clear? So we talked about induction last week. We briefly discussed causal reasoning. I want to talk a little bit more about causality, and then we'll move on to deductive logic for the rest of the class. I've got at least one interactive demonstration, well, I've got a QR code, but it's one in which it might be easier on a device with a keyboard, because I want to ask you to write just a little bit more. So the link is on there. So if you've got the slides, does everybody have the slides available? So if you've got the slides and you've got a laptop, that might be one case where the QR code is better served by clicking the link, unless you really like to type on your device. So it might take a minute or two to sort of type some answers. Okay, so what is causality? I think we all kind of know what causality is. That's when one action makes another action happen, right? Another way to say that is that the second action is dependent on the first action happening. Those aren't exactly the same. Knowing that one thing is dependent on another still makes it hard to determine what the causal mechanism is. So here is a graphic of a basic light switch from buildmyown.cabin.com. I'm not planning to build my own cabin anytime soon, but it sounds like it would be a fun thing to do at some point. Anyway, so you're going to build your own cabin. You're going to wire some lights. Or let's suppose you are building your own cabin and you need to put it in a new oven. You're going to want to wire something, right? So most of you, how many of you have more than just a cursory knowledge of how to wire things in your home? How many of you have ever wired something in your home, whether it's a light switch or anything else? So it's pretty straightforward, right? You can certainly imagine, even if you haven't actually tried to wire anything in your own home, and I wouldn't recommend it beyond pretty simple things because you have to do things properly. The light switch in here, in any room, operates sort of on the same principle. You've got a power source. You've got power coming from the outside world. That's hooked up to the hydro grid, right? And you've got a light that you want to turn on or off. And your causal link here is switching the light on or off. So I can switch the light off by pressing that button, and I can switch the same light on by pressing the same button, right? So I've turned the light off and I've turned the light on. I've caused it to do something. There is a correlation. Every time I press this button, the light's going to turn off. I'm not going to do it more than one other time. Every time I press this button, the light's going to turn back on, right? So there's definitely a relationship there. That's correlated. And if I keep doing it over and over again, and you measured how many times I did it, you would say, well, there's almost a perfect correlation. Every time I press that button one direction, light goes off. Every time I press it the other button, light goes on. Correlation, perfect correlation. Does the light switch cause the light to come on? So what is your interpretation of causality? What is the causal agent? What is causing the light to come on? What would be your best description of how the light is caused to come on in this particular case? What's causing the light to come on? What's the first thing that comes to mind? Voltage. So there's electricity. That's what's causing the light to turn on, right? What are some other candidates for the cause? What's making the light turn on? I mean, that's a good answer. Am I making the light turn on? Is my intention? Yeah.
The light bulb.
There's filaments in the light bulb. The switch itself, completing the circuit. My intention is really important here because in this particular case, the light's not turning itself on and off by itself, right? I mean, it's not just behaving erratically. There might be cases where light switches do this. There might be miswired switches where if I flick the switch, it doesn't turn on when it's supposed to. Maybe the hydro is out. Maybe the light bulb has blown out. You might push the wrong button. Then your intention to cause the light to come on doesn't work. Maybe I've pushed the wrong light switch. So the case that I want to make here is that causality can be really difficult to think about. All of these are candidates for the cause. The hydro running through, the voltage causes it. The filaments in this particular case, or the LEDs, complete that circuit. That's part of the causality. The actual manipulation of the switch itself, which is the case here, that's part of the causality. Is the switch causing the light to come on? My intention, my actions are causing the light to come on. These are all part of the causal mechanism. And it's hard to determine which one is the cause versus which ones are enabling conditions. And I think I talk about this briefly in the textbook, the difference between cause and an enabling condition. what we want to think about is the cause is the one thing that is most necessary. The one thing that's necessary, the one thing that appears to be the strongest candidate, is usually what we identify as the cause, whereas the other things might be considered enabling conditions. Hydro running through the lines in your house causes the light to come on, but maybe that's more of an enabling condition. It's just there. It's part of how your house is wired. Somebody still has to come in and flip the switch. That might be a closer or better candidate for a cause. So the point I want to make is that it can be really difficult. We talked last week about how causal things are correlated, but not all correlated things are causal. This will come back later in today's lecture when we talk about different kinds of conditional logic. So there are some models of causality which are closely related to models of correlation, but they consider a little bit more. And I want to talk about these for the next 10 to 15 minutes. The two things that most of us as humans and most animals, if you were to ask animals what causes something, they can't really answer, but they often behave as if they have caused something. How many of you do have a cat? I talk a lot about cats in this class. Cats can cause a lot of things, right? Mostly what they cause is, how many of you have a cat that cause you to do what they want by behaving in sort of cat-like ways, by scratching things and making lots of noise? And so what happens is they do a lot of stuff, and it appears as if they're doing it to get you to get up and give them some food. So this is a series of behaviors that they've acquired through operant conditioning. The cat knows, not in the way that we know, but the cat behaves in a way that if it does these things, somebody in the house, you, will eventually get up and dispense food. So these rely on some things, and two of them are cue contingency and temporal contingency, temporal congruity. Cue contingency means that when something happens, the other thing is contingent. So flick the light switch, the light coming on is contingent on that light switch being in a certain direction. That's cue contingency. If you notice which direction you've switched the light, then you would notice that contingency. Action B is contingent on action A. That means it's a candidate for a cause. Another one is temporal congruity, where it's easy for us as animals to be able to notice things that are related when they occur close in time. It's harder to come up with causal links when they are not close in time. It's a lot easier to feel well, I won't ask you to raise your hand. How many of you have ever eaten something or had something to drink or too much of certain kinds of things to drink, and then you're later sick? You can usually put those things together, right? I ate this and it made me sick. So there's temporal congruity there. If you're sick after drinking too much alcohol, you're aware of that connection, right? If you eat something that's bad and you have food poisoning afterwards, I do not want to ask for you to raise your hand, but you know what that's about, right? Getting food poisoning. And you'd be sick afterwards. So you can put those two things together because they're close together in time. They're close enough together in time. You remember eating a thing and you know what made you sick. It's a lot harder to think about causality with months or weeks or years. So the kinds of things that you might eat that could be detrimental to health over 20 years, that's really hard to think about the causality over a long period of time. So we're good at thinking about things when we can notice the cue contingency and when they occur close in time. It's harder to understand causality when it extends across long periods of time. So let's think about how this might be put into a matrix. And we're going to talk about a model of cue contingency called the delta rule. Before we get to the delta rule, which the delta rule just tells you about the strength of causal change, let's think about the sort of four possible options when you're thinking about whether or not something like a light switch or a cat's behavior or something you've eaten will have a particular cause. We've got an effect, whatever the effect is. In this case, let's keep with the light switch. The effect is the light coming on, right? That's what we're interested in. What makes the light turn on? We also have all sorts of candidate causes. And let's say we're just looking at one particular candidate cause, which might be manipulation of a light switch. We could do this for any potential candidate cause. There are four possible options. The effect is either present, in other words, the light's on, it turns on, or it's not present, the light's off. And the cause, the light is switched in the on position, is either present or it's absent. It is not switched in the on position. If we're talking about lights and switches and turning on, you would expect these two things to be high numbers. In other words, when the light is in the on position, the light's on, and when the light is in the off position, the light is off. And you wouldn't expect many observations to occur in the B and C. So this is what's known as a 2x2 contingency table. We've got cases where the effect that we're trying to understand is present or not, and we've got cases where the cause is present or not. And we want to fill these in. So let's think about something that seems to never go away, which is the relationship between childhood vaccines and autism. This is a simplified example. I'm not an epidemiologist. Epidemiology is a very complex science, so I'm not going to get into too many details about epidemiology, but I do want to talk about this particular relationship as an example. How many of you are familiar with the idea that the childhood MMR vaccine schedule may or may not cause autism later in life? Whether or not you believe this is true is a different issue. For a long time, there was no reason to think there was a link between these two things. Children were vaccinated. Measles, mumps, and rubella and various diseases were vaccinated for many years. In fact, measles, how many of you are aware that measles has come back, right? Because of a lack of vaccination. This caused me to think, am I actually immune to measles? I have no idea. Do you know how hard it is to find out whether you were vaccinated with something when you were born in 1970? It's not easy. Those records don't exist. I was able to determine that I actually am because I got a serology test. So I still have measles immunity because in 1970, that's when the US started vaccinating people for measles. My wife, who was born a year and a half earlier than I was, is not because she was born at a time when they had not yet rolled out the MMR vaccine. So the difference between 1968, 1969, and 1970 among adults. Anybody born before 1968 is likely to also be immune to measles because they probably survived measles outbreaks. So there's a very small window for people in my sort of older Gen X generation for which it's not clear whether they're immune to measles or not, because they may have not been alive during the time when measles was still around, but they weren't yet born at the time when it was when people were being vaccinated. So since the 1970s, the MMR vaccine has been given, and it was only in the 1990s that there was a belief that maybe it caused autism, that the particular schedule or something about this vaccine caused autism. Turns out it was based on fraudulent research. And most people agree that the particular study that kicked this off, which was published and later retracted from Lancet, was not a well-done study. And some of the research was fraudulent. So it was retracted. It's been retracted for a long time. And so for a long time, most people in North America understood that there was no link. Only recently in the US has the possibility of this link returned because of changes in the US administration. So this, we won't go through this one, but this is why the paper was retracted. There were only 12 child patients. Many of them did not have accurate vaccine records. Many of them didn't have clear diagnoses. So let's think about the relationship between vaccinations, specifically MMR vaccinations, and autism spectrum disorder in the United States, because that's where I have data from, in the relationship of this 2x2 contingency table. That means that you're looking at everybody in the US over a period of time for who might have had these vaccines. In other words, nobody older than me, because they wouldn't have been vaccinated. And you're wanting to understand present, the effect. This is, the effect is present, meaning individuals in the United States with a diagnosis of autism spectrum disorder. And possible causes, having received childhood vaccinations. Does that make sense to everybody? So these are the contingency tables. Those are the cases. So we've got people with the vaccine who have been diagnosed with autism, people with the vaccine who have not been diagnosed with autism, people who have not been vaccinated who have not been diagnosed with autism, people who have not been vaccinated who have not been diagnosed with autism. You can sort of imagine what the larger numbers are going to be in this case. So I've got the same 2x2 contingency table here, and now I've got a formula here which is going to be referred to as the delta rule. And this just tells you something about the strength of causal change that you might observe when there's a possible cause. It's similar to some of the other models we've talked about, and it's related to the idea of contingency and correlation. Delta P is the change in causal strength. As this number goes up, the likelihood that what you're trying to evaluate as a cause, what you're reasoning about as a cause, is likely to be stronger. As the number approaches 0, there's less relationship. So the same way you would interpret a correlation coefficient. And in order to do that, we take the probability of the effect, in this case autism disorder, when the Q is present, childhood vaccines. You calculate that probability by taking this sort of present cell and dividing it by the total cases when the cause is present. Does that make sense to everyone? So A divided by A plus B. In other words, all the time that people have been vaccinated, whether or not they have autism. And you subtract from that the probability of the effect when the Q is not present. In other words, individuals who were diagnosed with autism spectrum disorder who did not receive their childhood vaccines. So people who were vaccinated, people who were not vaccinated. If it's positive, then the cause might produce the effect. If it's negative, then the cause might prevent the effect. And if it's close to 0, then they're not believed to be causally related. Again, I'm not an epidemiologist. There are a lot of other ways to consider this. And even our discussion of the light switch suggests there are so many other factors. We're just talking about one in order to understand causal reasoning. So that's what we're looking at here. We can put some numbers in here. These are numbers from a few years ago from the vaccination rates and rates of autism spectrum disorder in the mid-2000s in the United States, at the time when people were most likely to think there was a link between these two. And it's about 320 million people in the United States in this particular sample. We've got out of 3.5 million people, of 320 million people with autism. So it's a fairly low rate. So these are individuals who have received their vaccine and also have a diagnosis of autism spectrum disorder. 3 million people in the United States. Then you also take into account people who received their childhood vaccinations but do not have a diagnosis of autism spectrum disorder. That's 294 million. It's a much larger number because almost everybody in the United States is vaccinated, certainly in this sample. So lots of people in the cause present, but only a small subset diagnosed with autism. You can also see in the cause absent, there are individuals who were not vaccinated who also still have the diagnosis of autism. Individuals who are not vaccinated who do not have a diagnosis of autism. And the number is still much higher for people who do not have the diagnosis of autism. When you calculate this, you end up having a fairly small probability of the effect when the Q is present and a small probability, even smaller probability of when the Q is not present. Subtracting this number from this number gives you a negative 0.009. In other words, a number very close to 0, suggesting that there's very little relationship between these two things. What's the reason why there would be very little relationship? This is going to come back when we talk about decision-making in 2 weeks. So what do you think of this, in this relationship here? What seems to be the single biggest factor that would undermine your belief or your understanding of the strength of the relationship between childhood vaccines and child autism spectrum disorder?
The fact that like so many people got the vaccine, but like autism prevalence isn't like blown up.
Yeah, so that's a good way to say it. And you were going to say something.
I was just gonna say like the rates of people being diagnosed with autism and like also just how it's being reported in general will affect how.
Yeah, so I think you're both honing in on the same idea. And I'll talk about this in 2 weeks, but it has to do with these base rates. The base rates of vaccination in the United States are extremely high. They still are. And that's true for Canada as well. Everybody gets childhood vaccines with a few small exceptions. And you can see that's true here. Of 320 million people, almost everybody is vaccinated. So high base rate of baseline vaccinations, meaning that everything else is viewed in the context of everyone's vaccinated. And there's a relatively low base rate of diagnosis of autism. Of 320 million people, it's not a large proportion. It's 3.5 million people seems like a lot, but out of 320, 340 million people, it's not a large number. It's a low base rate. And so this is what undermines the strength of causality. The fact that that particular cause, that Q, is associated both with people with and without autism. In fact, it's much more likely to be associated with people who do not have autism spectrum disorder. There are far more people who get their vaccines and do not, or are not diagnosed with autism spectrum. Did somebody else have a hand up? So we're going to come back to this in 2 weeks when we talk about decision-making and probability, and we'll make the case that humans, that is to say, all of us, really have difficulty with this kind of reasoning because we rarely have access to the base rates. If we don't have access to probability and base rates, what do we have access to? How do we tend to make these decisions? Representativeness and availability. We think about what comes to mind. If you if you hear that there is an increase in the diagnosis of autism spectrum disorder, you would be likely to think that it's a higher probability than it might already be. If you were to hear that there's a reduction, for example, maybe in people getting their vaccines, you might think that that is more prevalent than it might otherwise be. So we don't have access to base rates. What we have access to is what we hear about. In other words, what we have from our memory, availability and representativeness. So it makes it hard to reason about that. Okay, does that seem sufficient for causal reasoning? Causal reasoning is based on trying to understand strength between cause and effect, Q contingency, and temporal congruity. We're going to talk a little bit more about contingency later in today's lecture. But now I want to talk about deductive logic, and I've got a couple of examples we want to do. First, let's start with an example I've used before. If you took cognitive psychology with me, I think I used this example as well. This is an inductive reasoning. If I buy a coffee from McDonald's and I take a sip of the coffee and it's really hot, I like to drink my black coffee. Okay, so black coffee is going to be hot. I might conclude that McDonald's coffee is very hot. That's a generalization. That's a type of inductive reasoning. That's exactly how we define inductive reasoning. I observe things that are happening, and then I make conclusions based on those observations. It's not guaranteed. It's just what I think about the world. So this isn't inductive. It's a generalization, a form of inductive reasoning. But deductive reasoning is a little more complicated. So from this generalization, I might form a general premise. In other words, a statement about the world. And I could state this premise as McDonald's coffee is very hot. And that means a couple of things. If I state the premise, it means that it's always true. We assume that if a premise is stated, we're trying to say something true. So McDonald's coffee is very hot. That's a premise that is a state of affairs about the world. From a premise, we can then construct arguments to try to analyze things and make specific conclusions. Premise can be used to make conclusions, what we call deductions. And this is what deductive logic is about. Where deductive logic differs from inductive thinking or abductive thinking is that we try to structure the argument so that the conclusion is the only possible conclusion. A valid deduction is one in which the conclusion is the only possible outcome. Rather than something that's likely, it's something that's guaranteed. A valid deduction means that the conclusion is the only possible thing that it's the only possible conclusion you can make. We'll make a distinction between valid arguments, which are structural, and sound arguments. Sound arguments are those that are valid, but also based on true premises. We'll do some examples later where you can have a premise and a conclusion which appear to be valid. In other words, according to the structure of the argument, it's the only possible conclusion you can draw. But if the premises are false, then you draw a conclusion that is false. That's called an unsound argument. Anyway, combined with additional premises, we can create what's called a syllogism. All McDonald's coffee is hot. This coffee is from McDonald's. Therefore, this coffee is very hot. Now, this is stated as formal logic, but it's the kind of thinking we do all the time. If you start to think McDonald's coffee is hot and you've decided that's a true statement about the world, if somebody says, I brought you a coffee from McDonald's, you might predict or conclude that, yeah, this is hot because it's from McDonald's. You don't need to even try it. You should be able to understand that it's going to be hot based on your understanding of the world, if you're thinking logically. Most of us don't think logically all the time because it takes a lot of work, and I'll do some examples as to why it's so complicated. On the one hand, deduction seems intuitive. We think deductively, and we make decisions based on evidence. Here's another one. Your friend is waiting by the Starbucks or by the shoe store. If your friend tells you, look, meet me at the mall, I'm going to be either at Starbucks or by the shoe store, whatever shoe store that they would normally go to. I don't know what shoe stores they have in Masonville, but let's just say they tell you which shoe store. I'm going to wait here or there. You get to Starbucks because that's one of the entrance points of Masonville Mall, right? You go into the mall, there's the Starbucks on the right, your friend's not there. What do you conclude from that piece of information? You've got some basic fact. Now you've been given some information that one half of this is not true. Therefore, what do you conclude? The other half has to be true. This is another form of deductive thinking. This is conditional thinking. If this or this, you find out that one thing is not true, therefore the other thing has to be true. You go into Masonville Mall, there's the Starbucks, right? Well, actually, you go into the Marshall's HomeSense. That's my preferred entrance to the mall, mostly because I don't like Marshall's and HomeSense at all, so I can blast right through it and get to the places I need to get to. So you go through Marshall's HomeSense, and there's the Starbucks. Nobody's there. You make your way to the shoe store next. You don't have to check both places, right? You already know they're going to be at the shoe store because they've only told you one or the other. Once you've disproven one half of it, the other half is guaranteed to be true. Does that make sense? So logic is about trying to structure your thinking in such a way that when you finally make a conclusion, you're really confident in that conclusion because you can guarantee that that conclusion is the right one. But deductive can seem counterintuitive. There's a lot of Very rarely do we get to evaluate series of premises and conclusions, and even that can be hard. Most of the time, we're evaluating people's arguments based on lots of other information. We've got our own biases, we've got our own knowledge and our own memory. Even the shoe store and Starbucks example depends on your knowledge of the mall, right? It depends on which one you're going to get to first. It depends on your understanding of your reliability of your friend. If your friend is at Starbucks or the shoe store, are they distractible? Will they go some other place? So we're not usually doing logic like that. Yeah.
About the example, is that an example also of parallel syllogism?
Yeah, because what we're talking about is your friend is here or here. So either this is true or this is true. And then we find out that not something is true. We'll talk about these forms in more detail after this next example. Good question. So here's an example from a study conducted by a professor of philosophy and logic at Yale University way back in the early 1960s. This is before the Beatles. So it's so old that it seems pre-modern. So the example sounds kind of old-fashioned. What she was interested in was studying whether or not people could ever reason logically, even when they're in a logic class. So I'm going to read through this, and then I'm going to give you the QR code to think about this. But here's one of the problems she asked participants in her study. And again, this sounds like something from the early 60s, late 50s. A group of women were discussing their household problems. Mrs. Shivers broke the ice by saying, I am so glad we're talking about these problems. It's so important to talk about things that are in our minds. We spend so much of our time in the kitchen that, of course, household problems are in our minds. So it's important to talk about them. So this is just sort of sounds like some kind of random nonsense conversation that people are having to break the ice, right? She's asking, okay, you understand logic. You're students in my logic class. Is this a logical and valid deduction? In other words, is Mrs. Shivers' conclusion, it is important to talk about them? Is that valid? Is that the only possible conclusion you can draw? In other words, did she actually make a valid logical argument? So think about this from the standpoint of trying to come up with a valid deduction. Is it important to talk about them? Does it follow? So here's your logical form. I'm going to ask you two questions. One, is this a valid deduction? In other words, think about all the things. Is Mrs. Shivers' conclusion the only conclusion you can draw based on what she says? Or is it not logical? Is it not the only conclusion you can draw? And then tell me why in just a few words. And then we'll look at some examples. This might take about 5 minutes. I'll give you about 5 minutes. You don't need to write a paragraph, just a couple of sentences. Wait another 2 minutes. And even once I bring up the answer, you can continue to finish. Okay, if you're still typing in your answers, it's okay if you want to continue. Let's look at some of the examples, though. We don't have to have everyone in here. So we've got the same syllogism here. And we're split almost right down the middle, but a small majority of you, well, actually 60%. So 60% of you, almost 2/3 of you. Now it is 60%. Thank you for that last push over the edge. So we're almost 2/3 of you think this is not a valid deduction. And we'll look at some of the reasons in a bit. And about 1/3 of you think this is a valid deduction. It's still 2/3, so thanks for continuing to support this. So let's look at some of the details here. Somebody says premise 1, spend time in kitchen, have problems in kitchen, conclude many, they can talk or don't talk. It is valid because P1, it's important to talk about things in our mind. Household problems on our mind is important to talk about household problems. That's a pretty good answer. Because there are many different things that could go on in someone's minds, weather, family, etc. Not valid. Because household problems on our mind doesn't necessarily mean they have to talk about them. That's also an interesting point. Someone says it's not the only conclusion. It's a circular argument. If you said it was a circular argument, why would you say it's a circular? So what's a good rationale for saying it's a circular argument? Anybody want to volunteer? I mean, it sounds circular because somebody says, hey, this is a thing. It's important to do this thing. Therefore, it's important to do this thing. That sounds a little circumspect, doesn't it? It's like somebody just declaring something. Well, it's important to talk about stuff that's in our mind. So you got to start believing that premise. Someone says the way the premises are set up lead that to be the only conclusion. Someone here endorses in a very non-committal way, I guess it's valid. It's valid because the kitchen is in the house. I like that. That's exactly the right answer. Let's look at a couple of other options. So last night I asked Anthropic Claude to answer this question. Anthropic was in agreement with a lot of the class. Anthropic says no, emphatically, bold, the conclusion is not valid, but then starts to back away from that. Mrs. Shivers commits a logical fallacy by assuming that just because something is on your mind, it's therefore important to talk about them. That's where this gets really difficult, because if we constrain the logical thinking to just what is said, that's a premise we're starting from. We're not taking into account all of the other possible things. If we take Mrs. Shivers at her word, that's an important thing, it's important to talk about things that are in your mind, that can be a premise we start from. So the question is, where do we start? Anthropic says it's a shaky premise. Then sort of walks it out exactly like some of you did. It's important, this is in our mind, therefore it's important. Then it looks valid, so it's starting to back off. And then it says it's formally valid but unsound. So Anthropic actually talked itself out of its first conclusion. Its first conclusion was no, this is not valid. Then it sort of backs off and qualifies it and said it's valid but unsound. And then I said, if you restate, we won't go through the entire example. It says, let's map it out. Then it says it's modus ponens, which it's not. Yes, it's formally valid. And then I said, are you sure this is modus ponens? Then it says, let me reconsider. And then it comes back to the statement that we originally set up. So one of the reasons I bring this up is that this is, Henley discovered in 1962 that this is a really difficult thing to reason about. Even if you can strip all of the meaning away and assign a logical structure, you would come to the conclusion that this is a valid deduction. The form is valid. So anthropic is correct, and 40% of you were more or less on the right path for this. There we go. Let's hide this. So what she found, here are some of the answers that her participants gave. No, it is not valid. And then suggest that it's not valid because it's not important about the things to talk about our minds unless they worry us, which is not the case. And so she suggested this is not the right answer. It is formally a valid structure, but this isn't really the right reason. Because the person in this particular case, like a lot of us, and like Anthropic as well, suggested that there are lots of other things going on. In other words, it brought other assumptions to the table. This is not something that Mrs. Shiver said anything about worry. So this is bringing additional information to try to determine whether or not this is a logically valid argument. Another person is correct. Yes, it is a valid form. It's important, but then suggests that maybe you got to get stuff off your chest, but not for any reasons, and gives a lot of other rationale. What Henley discovered was that it's really difficult, even for students who are trained in logic, to reason logically without bringing to bear all of the other information. So you just naturally start making assumptions about things. And it's really difficult to ignore those assumptions. In other words, it's really difficult to reason through something without thinking about other things that you know. That's one of the reasons that logic is difficult. And so what many of you concluded, and what Anthropic Claude eventually concluded, is that this could be a logically valid structure. It's important to do one thing. This is one of the things that is in our mind. Therefore, it's important to talk about our problems. You could even restate this, that it is important to do A. B is equal to A. In other words, A is true, and therefore it is important to do B. So you can strip away all of the meaning and conclude that this is a logically valid structure. But most of us can't strip away all the meaning. In fact, that runs counter to how we think. Stripping away all the meaning is not how we think. That's the opposite of how we think. We always add extra meaning. So that's one reason that deduction is cognitively tricky, because it's really difficult to ignore everything else. Yeah.
Was this study like made before like logical reasoning standardized tests were a thing at the LSAT?
That probably is, I'm not sure about that. But these would have been students in a philosophy class at Yale University. And so probably there was at least some background in formal logic. And so most of these logical forms have been developed over hundreds of years. So students who study logic are familiar with them. And then when I read through Anthropic Claude's transcript, it came up with some good candidates for what kind of logical structure this was. It was wrong sometimes. And you all know this when you use, whether it's ChatGPT or Copilot or Gemini or Anthropic or any other general artificial intelligence, you know it's wrong sometimes. And you can talk it out of its conclusion. You can argue back with it and get it to come up with a different conclusion. Sometimes that's helpful. Sometimes that can be a little harmful if you take it at its word. So it's difficult because it's hard for us to ignore all of the context. That's the opposite of what humans do. There's another reason that it's difficult, and that's because it's cognitively demanding. What do I mean by that? Let's watch this short video. Let me give you a little bit of background here before I start it. Let's make sure it's not too painfully loud. There's no sound at all now. If there's no sound at all, that's not going to be helpful. Am I missing a setting here? This says volume, right? Is there something that's muted here? How do I make it bigger? It's not necessary to watch this short video. You can watch it later. And I'm on mute now. Program volume is not on mute. Is there nothing? And there's no subtitles. Does anybody know this video? It's from the movie Labyrinth. It's a great movie. Okay, I guess we're not going to watch this short video today because it appears to not be, there's sound. Look, it's blasting away. It's wired display. Now, this has worked for me in the past, has it not? We have watched videos in this class, haven't we? This is like a 2-minute video. Nothing. Connect a cable to CAF. What does that mean? PC screen only. I have no idea how to control the sound here. Well, I'm going to give up on it because there's no point in me sitting here clicking things and trying to make the sound work. Let me explain this you can watch the video later. The point that I'm going to make with this, and I do talk about this in the textbook, and I do recommend watching this short video because it's kind of fun anyway. But let's go back to my lecture here. Okay, so in this example, you'll watch the video later and we'll talk about this particular example. She's confronted with 2 doors, and this is a version of what's known as the knights and knaves problem, which is a problem which is a classic example in problem solving and logic. In this case, you're given just a little bit of information, and your job is to reason through the small amount of information that you have to try to figure out what the right answer is. What happens in this particular case, the protagonist has to go through one of 2 doors. One door leads to the castle where her infant baby brother, who has been abducted by the Goblin King, who was played by the late David Bowie for some reason. That's what she wants. She wants to get her baby back and I guess meet David Bowie. In the other door leads to certain death. We don't really know what kind. So only one door is good. There's a good door and a bad door. And each door is guarded by a guard. And the guard there's a red door and a blue door. And what they tell her is that one of these doors leads to the castle, one leads to certain death, and one of us always tells the truth, and one of us always lies. Presumably after that is when they start telling the truth and lying, because that has to be a true statement. So that's when the game starts. One of us tells the truth and one of us always lies. How is she going to figure out which one of these 2 doors to pick? If she asks the one who's always lying, any information is going to be untrue. If she asks the one who tells the truth, that's great, but she doesn't know which one is the truth teller and which one is the lie. So very quickly, she comes up with a solution. And the reason I like the video is that it goes by so quickly that it's really hard to keep it straight. And the argument that I want to make is that logic can be really cognitively demanding. You have to keep straight a lot of different moving pieces. You've got to keep facts and facts that are connected to other facts. And that requires working memory. That also requires attention. And that requires the ability to consider multiple alternatives simultaneously. And if there are a lot of other things going on, and if you're under a lot of pressure, like your baby brother has been kidnapped and one of the other doors might cause you to die, that pressure could also make fast decisions. So it's a good video to watch for that reason. It's pointless to watch when there's no audio because you can't hear the reasoning. So she solves the riddle. Here's how she does it. So she says one single question solves the riddle. She says, she asks one door. She asks the red guard, would he tell me that this door leads to the castle? In other words, she asks red, would blue tell me that this door, red, leads to the castle? And red says yes. And from that piece of information, she's able to reason that blue is the right door and red is the wrong door. And she explains her reasoning really quickly. The ways you can do this in a problem like this is with this if-then statement. We talked about this with Starbucks and the shoe store. In my final exam, there's also a problem that wants you to think about these kinds of conditional A, B, if-then statements. So if red is telling the truth, then blue is a liar. So she asks, she asks red, would he tell me that this door leads to the castle? If red is telling the truth, then blue is a liar. Blue would say that red leads to the castle. It would be a lie. Therefore, red does not lead to the castle. So in other words, she knows that when blue says yes, if red's telling the truth about that, if red is telling the truth about what blue would say, then blue is telling a lie. In other words, if he says yes, it's the wrong answer, it's a lie. She can get exactly the same thing from asking the same question. If red is the one telling the lie, and what red says about what blue would say would actually be the lie, meaning that blue's answer is the right answer, and therefore, again, blue is still the right door. This example in class works a lot better if you've actually seen the video. It's a little harder to explain without the video going forward because I might not have chosen a blue-red guard castle example to work through this. But if you could just stay with me a little bit and understand the point that I'm trying to make, which is keeping all of these things straight can be a challenge. So most of us choose not to reason rationally for two reasons. One, we can't ignore context. All of our knowledge, even if it's irrelevant knowledge, continues to intrude on the decisions we're trying to make. That's how your mind usually works. And second, it's really difficult to keep all of the different moving parts straight, as this example would have shown really well if we would have been able to watch the video and follow. Does this seem clear enough for now? Watch the video later in your privacy of your own home. Enjoy the short description. Watch the whole movie. It's a great movie. And then come back to this example and think about how you can work this out. Okay, so it's 10:37. We do have time to make it through. I believe there are a couple of options here. We're a little ahead of schedule. We can either take a break now because this is a conceptual break, or we can blast ahead without a break and maybe finish by 11:45. Does that seem reasonable to people? Who would like a break? Just vote with your feet. You can actually take a break if you want. Are the majority of you okay if we continue breakless so that we're able to end early? That said, if you need to take a break on your own, stand up or go out to use the washroom, that's fine. But we're all okay with that? All right. So I mostly want to talk about two forms of logic. I'll go through this as quickly as possible, and we should be okay. If only this would, there we go. So we've talked about, we're going to talk about categorical knowledge, categorical reasoning, and conditional reasoning. Categorical reasoning is similar to the type of categorical induction we talked about, but now we're talking about whole classes of things. Conditional logic depends on conditional statements. So these are the kinds of syllogism. This is a category. All McDonald's coffee is hot. In other words, we're making an assumption, a claim about everything. The category of McDonald's coffee overlaps with the category of hot things. This coffee is a member of this category, and therefore it is also a member of the other category. So this is a categorical statement. Structure of logical tasks. This syllogism has components. This is true or this is true. And we can determine the truth or falsity of this by collecting additional evidence. So categorical syllogisms rely on this idea of a classical model, that When something, an object or an entity or predicate or an item, is a member of a category, it inherits the properties that are true of that category. We've already suggested this classical model might not be the best model to describe how humans make categorical decisions, but it is a reasonable way to understand how you might be able to make logical decisions. So we're reasoning about a whole class or a category. There's 4 different ways. I've described in the textbook at least 4 different ways. Now, there are lots of ways to construct logical arguments. I find this particular way of using these Euler diagrams, not Venn diagrams, but Euler diagrams, these circle diagrams, to be a fairly simple and straightforward way to explain how these different relationships occur. So there are 4 kind of statements. And by putting these 4 statements together, we can determine whether or not the structure of an argument is valid or not. A valid deduction in this case is one for which once you've seen all of the arguments, once you've seen the predicates, and the premises, that the conclusion is the only one that you can draw. With a circle diagram like this, the way in which you might do that is to map out all of the possible ways in which a statement would be a true statement. And once you've mapped all those out, if there isn't any arrangement that allows the premises to be true, but an alternative conclusion to be drawn, then you have a valid structure. So the first of these we would refer to as a universal affirmative. In other words, it's universal because everything in the category is under consideration. And it's affirmative because it's saying something positive about what's in that category. We can frame this as all A's are B's, all somethings are something else. In the next example, I have all cats are pets. It's the same slide. In other words, everything that's a member of category A is also a member of category B. This is one way in which that statement is true. So I like to think about this as the entire universe. This is a universe that has only 2 things in it. Nothing else in this universe. This is a very simple universe. There are 2 concepts, 2 categories. One category is a subset of the other. The larger category is B. In this case, the larger category is pets. All the pets in the universe. This is a universe with only pets. And some of those pets are cats. This statement, all cats are pets, would be true in 2 different kinds of arrangements. It would be true in the case where there are lots of different kinds of pets, of which some of them are cats. And it would also be true in the arrangement where cats and pets are the same thing. In other words, both categories are entirely synonymous with each other. Those are 2 different arrangements, but the statement, all cats are pets, is true in both of them. Does that make sense? So that's the universal affirmative. In a universal affirmative, there are 2 ways for the statement to be true. In other words, this predicate is true in 2 different universes. Here's one universe, here's the other universe, statement's still true. A particular affirmative is one in which you're saying something about some of the category members. It's particular. It doesn't mean everybody, it just means some. And you're still making an affirmative statement. This statement, some B's are A, in other words, some things that are members of category B are also members of category A, can be true in 4 different ways. There are 4 different universes in which this statement is still true. 2 of them seem really obvious. The other 2 seem less obvious, but you'll see why in just a minute. Some B's are A. It's true in the case where A's are a subset of B. Here are some of the B's that are A's. They overlap. And here are some of B's that are not A. Does that make sense to everybody? So that seems really particular. Here's another case. There's a universe where A is a group of things, B is a group of things, and they intersect somewhere. That means there are some B's that are not A's and some A's that are not B, but some B's are A. That's another case. If you say some B's are A and you live in that universe, you've made a true statement. Here are 2 others where it seems a little less straightforward, but if you live in the universe where A and B are identical to each other, and you say, some B's are A, your statement is true. It's not rendered false by this universe. It's kind of an incomplete statement because you live in a universe where A and B are the same thing, but you can't be proven wrong when you say that. Does that make sense? So that, I think, is one of the cases where it seems a little more complicated. Here we live in a case where A and B are the same, but we're saying some B's are A. It's the same category, but the point is your statement would be supported by the evidence of the universe that you live in. And the same is true here. Even where B is a subset of A, if you say some B's are A, if that's the statement that you're making, if that's your premise is supported by the arrangement of facts in the universe that you live in. All four of these arrangements support that statement. They don't disprove that statement. Does that make sense? So we got a universal affirmative, a particular affirmative. I'm going to skip the cats and pets because it's actually redundant and it's a little more complicated. I kind of find A and B's actually being a little better, even though it took me a long time to find lots of little shapes. I'll just leave them up there to appreciate it. And then I'll move on to the next one, which is a universal negative. There's only one universe you can live in and make a universal negative statement, and that's the case where the categories don't overlap at all. So if you live in a universe where A and B share nothing, then you can reliably say no A's or B's. Does that make sense to everyone? And then finally, there's a particular negative. Some A's are not B. This is true in 3 different universes. It's true in the case where there's a lot of A's that don't overlap with B. It's true in a case where they intersect here, because here are some A's that are not B. It's also true in the case where they never overlap, because if you live in this universe with those 2 categories, those 2 classes do not intersect, and the statement is some of the A's are not B's, your statement is still supported by the arrangement of the classes in the universe. Does that seem clear to everybody? So the reason this matters is that if you want to determine whether or not a series of statements produces a valid conclusion, you can run through all of these possible arrangements. If you can draw all of the possible arrangements and still only come up with one conclusion, then you've made a valid deduction. If you run through all of the arrangements and one of them produces an alternative conclusion, then you have a non-valid arrangement. I'll show you how that works. So logical structure determines if an argument is valid or not. And this is regardless of perceived truth. There are lots of cases where an argument can be valid and you don't believe it. And that's where logic is difficult, because we can't always turn off our beliefs. We can't always turn off what we think is true, regardless of real world knowledge. You might know cases that confirm or disconfirm the conclusion. If you know a case that confirms or disconfirms a conclusion, you're more likely to go with what you already know. And so it's really difficult to turn off availability and to turn off your mind in this case. Soundness, we talked about soundness earlier. Soundness has to do with whether or not the premises themselves are acceptable. You can create a logical structure with unsound premises. A sound argument is one that is valid and based on true premises. An unsound argument is one that can be valid but based on false premises. So in this case, all sound arguments are valid, but not all valid arguments are sound. Does this make sense? Yeah.
So with like that previous statement about like important things on our minds we talk about, like would that be like a valid but not a sound argument?
That's a good interpretation. So it's a valid argument. It may not be a sound argument. And that's what the artificial intelligence system also determined, is that maybe it wasn't sound. And there are lots of examples of unsound reasoning because we don't always know the truth of the premises. It's easy in a case where you've just got A and B, right? And you've just got circles and universes of only 2 things. But when you're thinking about real world events, it's a lot more difficult to reason logically. This brings up an idea known as belief bias. Belief bias is the tendency to endorse deductions based on whether or not you believe the conclusion. This makes sense. We tend to think that things that align with our beliefs are true. Things that don't align with your beliefs are less likely to be true. And so what do you think the reasons would be for that? So what's a good candidate for an explanation for a belief bias? We'll talk about the belief bias effect now. But why would you tend to be better at endorsing valid conclusions? In other words, be better to determine whether or not a conclusion is valid just because you believe it. What would be the kind of thinking that goes on with?
Maybe because of associations you already have or looking at the formal logic.
Yeah, I mean, if you already start to think you know what the conclusion is, you said associations that you already have. If you already start to know what the conclusion is, well, look, we already discussed that logic is challenging. It's cognitively demanding. It's hard to do. It requires a lot of working memory resources. It's cognitively resource intensive. If you can get the answer easier by having something come to mind, your own knowledge, you're going to do that. Your mind is going to use a system one approach. In other words, if you've got the answer, you're not going to do the logic problem. If you've got a belief about something, it's really hard to make yourself work through the logic in a way that sets your beliefs aside. This suggests, and this has often been used to sort of support the idea of this fast and slow, this dual process account. The idea that we come to conclusions faster if we already have the answer rather than working through the problems ourselves. So belief bias. Let's do 2 examples of belief bias and then talk about some of the brain aspects of belief bias. I'm glad they're working on that drinking fountain right now. So all doctors are professional people. This is a pretty basic universal affirmative statement. And one that seems reasonable, right? Doctors are a member of the class of professional people. This is a universe as only doctors and professional people. Doctors are a member of that class. Some professional people, some members of the professional people class are also members of the rich people class. And then we're asked, is it valid that some doctors are rich? Is this a valid conclusion? In other words, if we've got professional people, doctors are a member of them, and then rich people, some professional people are rich, some are not. This is probably what you have in mind, right? Maybe because you know at least one doctor, a physician, or some kind of medical doctor who also happens to be rich. It's technically possible, right? You may know rich doctors. You may be related to rich doctors. Your parents might be rich doctors. Your own doctor might be rich. Not every doctor is rich, but it's possible that some could be. If you know at least one, this seems like a pretty valid conclusion, doesn't it? If you can come up in your mind with an example, a plausible example. So in other words, you might believe this conclusion. I believe this conclusion. This conclusion is believable to me because it is possible to be a rich doctor. It's even possible to be a rich doctor, not through the practice of medicine, but just because you're a rich guy and you decided to become a doctor. Now you're a rich doctor, right? It is possible. But it is not a valid deduction as it's structured in this case. Should I just close the door? Does that sound distracting? Because it feels distracting to me. Maybe I'll just... because we needed that water fountain to work today. I think he heard me. I mean, don't get me wrong. I'm glad that Western is maintaining things. It's just that it's right now. We're both just trying to do our job. He's trying to do his job out there. I'm trying to do my job in here and now. It's a little better. He doesn't have to listen to belief bias, which is irritating in its own way. So professional people are rich. All doctors, professional people, some are rich, some doctors are rich. It's not the only possible arrangement. And this is what I mean about thinking about these circle diagrams. You can imagine ways in which the universes overlap. It's not valid because it's possible for both of the premises to be true and a different conclusion to be drawn. In other words, you could have a case where So all doctors are members of the professional people category. Some professional people are rich, but it's possible to imagine that arrangement in such a way that none of the doctors are included. And this, don't get bogged down in the specific arrangement of where I put the circles. The point is that it's possible to think about each of these conclusions. This arrangement, all doctors are professional people. Statement is true. Some professional people are rich. Statement is true. Some doctors are rich. Statement is not supported by the evidence. And that's the point that I want to make, is that when you think about these, this would be a non-valid deduction if you take the time, but none of us would. Belief bias works because we already know the answer. We don't need to take the time. And your mind is structured in such a way that if you've got the answer, you don't want to go through a lot of extra work and cognitive resources and time and effort to try to come up with a conclusion you already know the answer to. It would be a waste of resources, and that's what belief bias is all about. This gives evidence for this dual process account, fast system and a slower deliberative system. One of the tenets of the dual process account is that if the fast system can provide an answer, we prefer that. And sometimes it's wrong. So this belief bias task is when we set up a conflict. So I'll go through a couple of different examples. We can set up conflicts, cases where premises are valid and believable, valid and non-believable. Also, not valid, not believable, not valid and believable. And we should see faster, better reasoning for cases when there is no conflict. In other words, when the validity of the argument is supported by your own beliefs, you should be fast to say yes to valid and fast to say no to non-valid if you already believe the conclusion. If it takes you longer, that suggests you're actually using system 2 to work your way through it. And so we can have things like a valid tasks. This is a valid deduction. No C's are B's, some A's are B's, no A's are not C's. I won't take the time to go through all the circles, but this is a valid deduction. The statement support the conclusion. This is the only possible conclusion you can draw from these statements. And so we can draw them out, we can draw them out, we can draw them out. We can then put in the same structure. So I've given you a structure that in the abstract is valid. We can put in things. No cigarettes are inexpensive. This is already hard to think about, even the statement itself, right? Because you've got a double negative. No cigarettes are inexpensive. What does that really mean? It kind of means cigarettes are expensive, but it doesn't really mean that. It means that no cigarettes are inexpensive, right? So it's really hard to think about what that statement means. So we're already off to a tough start here. Some addictive things are inexpensive. Again, I guess that's okay. I think I understand that you can be addictive to things that are not expensive, but it's another piece of information and it's kind of complicated to keep them straight. I got a double negative and I've got this particular affirmative, and then I'm asked to say some addictive things are not cigarettes, and I don't take the time to bother going through all of the actual statements because I know it is possible to be addicted to things other than cigarettes. So why would I go through the time to draw out all these circles when I already know that heroin is a thing, right? It's addictive. Gambling is a thing. It's addictive. They are both not cigarettes. I can come up with the answer. It's valid and believable. It's easier to reason. There can also be statements that are valid, same structure, but harder to believe, or at least harder to come up with an answer. No addictive things are inexpensive. Again, that's also kind of a hard one because I've got double negatives. Some cigarettes are inexpensive, therefore some cigarettes are not addictive. Do you have any ideas of cigarettes that are not addictive that some might be? I don't have any ideas. But this is a valid deduction. It's valid because if you work your way through all of these statements, inexpensive cigarettes are not addictive. In other words, the cheap smokes don't get addicted to them in this particular universe. So, well, we don't believe that, right? We believe that cigarettes are actually addictive. We know that they are, regardless of how cheap they are. And so this is valid, but it's difficult to believe. And so this should be more difficult to reason. which one of these uses system one? This one, because you already know the answer before you even get to it. Which one is going to need system two? This one, if you really want to come up with a statement and have that statement be accurate, it's going to take you longer because you really need to draw these out. Because you can't come up to mind with anything that is cigarettes that are not this category. You don't have a ready example from system one, so you got to work your way through it. You can set up cases where there are conflicts. I won't go through all of these, but essentially a conflict is cases where it's either valid and not believable or not valid and believable. In other words, it's not a valid deduction. This is like the doctor of professional people. It's not a valid statement, but the conclusion seems reasonable. No conflict is where the believable ones are valid and the not valid ones are also not believable.
Yes.
Soundness in this case means that the premise is a true premise. So they're solid premises. Many of these are questionable soundness. When you make statements about no addictive things might be cigarettes or no cigarettes are inexpensive, you question whether or not all of these are sound. This is a case where we want to just understand the reasoning process. Does that make sense? But sound arguments are arguments that are valid, but based on good premises that you accept and understand. Generally, what you find is a pattern like this. For valid deductions, this is the number of conclusions that are accepted by participants in a study. When they're valid and believable, so green or believable, people usually get them right. When they're valid and not believable, people get them wrong in the sense that they endorse them when they shouldn't. When they are invalid but not believable, people get them right in the sense that they do not endorse them. And here it's really tricky. When they are believable but not valid, again, people get them wrong in the sense that they say yes when they shouldn't. So we show a preference for accepting logical statements that align with our belief. And we show a preference for rejecting logical statements that rejecting as illogical if they also align with our beliefs. In other words, we reason from our beliefs. That's much easier for us to do. And we tend to do it most of the time. We already believe the outcome. It's easier to believe in the logical statement. Very briefly, look at a study. I won't go through the details. This is a study from a while ago, but these results are pretty solid, and most of this work holds up. This is from York University. Asked people to do these belief bias tasks. So some of the reasoning tasks required belief, and other cases, they didn't require belief. They were either neutral or they were these conflict cases. And then they carried out an fMRI study. So they're scanning areas of the brain. And so again, you've got belief-laden reasoning. It's either valid or not valid. It's either true or false. And so when you believe the conclusions, you should say yes when they're valid. You should reject them when they're not valid. And then they have some things that they called belief neutral, which had essentially nonsense terms. So these are kind of like the A and B terms, but they sort of fit a structure with words. You don't have any pre-existing beliefs about these things. And so your only choice is to use system 2. You have to go through the reasoning work. They give you the stimulus. They ask you to reason through it while they measure blood activity in your brain. Mostly what they find, we'll skip through this one really quickly, but essentially what they find is a confirmation of this belief bias task. Participants were more accurate when belief and validity were in alignment. So your accuracy tends to be higher when these were belief tasks. Importantly, belief-laden reasoning. In other words, cases where it aligned with your beliefs, where you were likely using system 1, increased activation from a temporal lobe, reflecting greater involvement in memory retrieval. So likely people were thinking about the answer. When you were engaged in reasoning tasks that you couldn't really think about from memory because you didn't have any memory from it. You weren't using your beliefs. You saw lower activation from temporal areas, suggesting less involvement from memory retrieval. Does that seem clear to everyone? So there does seem to be a real thing going on here. You retrieve memories and you make deductions based on your memory and your beliefs rather than on logic.
Was there a delay in determining if it was valid? Let's say if the premise one was a universal negative, and then the premise two was like uh negative like essential, like a sum not, and then
Yeah.
the conclusion was a sum not as well. We'll determine if that was valid, like yeah, with more time. Do they need more time?
I don't know the answer to that. I'd have to look specifically at each one of their examples, but likely that's the case. So even in non-belief cases, if the task itself was a little bit more difficult, it should take longer for these more complicated cases. Briefly talk about some unsound arguments. Is everybody okay? We're actually on time to be able to end at probably around 11:45. Is everyone all right with staying till around 11:45 without the break? I know it's a little much to go breakless. All right, let's keep going. I really hope I actually do end at 11:45 because I don't want to feel like I gaslit you into staying without a break because I could have used a break too. And it seemed like we were going around all fine. Unsound arguments, you've got a lot of cases where the argument might be true. This is one that, again, I don't want to spend much of our class talking about politics in the United States. But a lot of things happen fast in the US. So many things have happened in the current Trump administration that it's hard to remember particular things. But how many of you remember about this time last year that new tariffs were announced to Canada? What was the reason? What was the reason for the emergency tariffs that were recently struck down by the Supreme Court?
Fentanyl.
Fentanyl, which was streaming into the United States from Canada, causing a national security risk, which was the rationale for emergency powers, which is why those tariffs were brought on board. That's the particular case that was struck down by the Supreme Court a few weeks ago. But it's a logically valid argument in a sense, if the premises would be accepted. This is an example of an unsound argument. If A is true, then B. So if A, then B. If there's evidence for A, then B. This is an argument structure we're going to talk about in just a minute. A modus ponens. This is one of the easiest kinds of valid structures to evaluate. If A, then B. You've got evidence that A is true, therefore B is true as well, right? So if fentanyl is streaming across the Canadian border into the United States, then institute across-the-board tariffs. That's a premise. The premise then could be fentanyl is streaming across the border. Therefore, we should institute tariffs. So at least one of these premises seems unsound and not supported by facts. But the structure is one that aligns with people's intuitions of a valid structure. This does seem like it's a reasonable statement unless the premises are not supported. So this would be an example of a valid argument, but one that's not sound. We'll see in the next example that just concluding, even without providing premise information, commits a logical fallacy. This is known as conditional reasoning, and this will be our mostly last topic. So we'll talk about this in a couple of different ways, but we're going to spend the rest of the day talking about conditional reasoning. Conditional reasoning is one that we're actually faced with a lot because it aligns with our idea of causality, and it helps us make sense of the world. We want to know what comes next. We want to know what's conditional on the next thing. And this is one form of it. If A, then B. Each one of these statements can be either supported by the evidence or not. And we just saw that with if fentanyl is streaming, then institute tariffs. Premise 2, fentanyl is streaming across the border into the United States. Therefore, tariffs are the next thing that happen. Here's an example I've used in class before. Studying. When you study, you get a good mark on your exam. So studying leads to an A, right? You get an A in your exam. If every time you've studied really well for an exam, you've done well, what would that lead you to conclude? If I study, I get an A, right? That's a pretty reasonable conclusion. That's how we conduct ourselves as university students, right? We study to get A's. So you conclude, if I study, I will get an A in the exam. How naive you were, right? Until you hit Psychology 1002. And you studied and you didn't get an A on the exam, or whatever class it was, right? You think like, I can study, I can get an A, but sometimes it doesn't happen. So if you form this premise, if A, then B, if I study, then I get an A, you should say that anytime I study, I am now studying. You would conclude I'm going to get an A, right? That would be the valid form. That is a valid form of reasoning. But think about the ways in which this might actually play out. One way is affirming the antecedent. This is called modus ponens. Modus ponens is sort of the example that we gave with the tariffs. Why did my watch buzz and there's no notification? Affirming the antecedent, it's called modus ponens. It just means the mode of affirming. Because a lot of things, we make a statement of belief. If this happens, then this happens. And then we look for the first thing to see if the next thing's going to happen. That's basic conditional reasoning. If I study for an exam, I get an A. I studied for the exam, therefore I get an A. This is the antecedent. If this is the affirmation of that antecedent. It's the evidence. I have evidence now that I've studied. Same thing happened with the fentanyl example. If fentanyl, then tariffs. Yes, there's fentanyl, therefore tariffs. That's a conditional statement. This is not of interest to me. I'm just seeing some family group chat come up because I forgot to put it on Do Not Disturb when my lecture, which I often do. That's a valid form. Another valid form, you did not study. How many of you have not studied for an exam? Sure, it happens all the time. Let's suppose you live in the universe where if you don't study, this is the answer. You fail the exam because you didn't study for the exam. However you want to define studying, you didn't do it, you're going to fail the exam. So this is what's called denying the consequent. And this again helps you understand the relationship. If I study for the exam, I get an A. You get the exam back, you did not get an A. The only thing you can conclude about this is that you did not study properly. Right? Again, we're just looking for, in this case, the denial of the consequent. If the consequent is dependent on the antecedent, and there's no evidence that the consequent occurred, the antecedent could not have occurred. If that first premise is true, if we know that's a sound premise, if that's a premise we understand, we have no reason not to believe it at this point. If you study and you get an A, if no A happened, then you couldn't have studied, because otherwise you would have gotten an A. Does that make sense to everybody? So these are logically valid forms. They're logically valid forms that express the relationship between the antecedent and the consequent. Set aside your belief about things. We're just talking about the form right now. But even if you set aside your belief and you just talk about the form, there are other ways to understand this relationship. For example, studying leads to an A. We already have decided this. If you study, you get an A. But look at all the other ways you could get an A that don't depend on studying. It could be really easy. You could cheat your way to an A. It could be a mistake. You could have not studied and answered all the questions wrong, but there was a marking error and just happened to go in your favor and you got a good score. So there are other ways, even if that relationship is true, studying and getting an A, that would still point to an A. Because the statement leaves those out. It doesn't say anything at all about all the other things that might lead to an A. In fact, if you took a course for which the only possible grade was an A, everybody passes the class, everybody gets a grade. I gave you the answers to every question and told you exactly how to answer the exam questions. Everybody gets an A. I'm like Oprah, handing out A's. You get an A, you get an A, right? You can study or not. The relationship, if I studied, I get an A, is still true. but everybody gets an A, including the people who didn't study. Does that make sense? So the statement is true, but we live in a universe where A is the only outcome. So this is an invalid form. In other words, affirming the consequent doesn't tell you anything. So if I study for the exam, whoops, I get an A. I did get an A. So I have evidence that I got the good exam or the good outcome, affirmed the consequent. I can't conclude with certainty that studying was the cause of that because I haven't been able to rule out all of those other things. So this is not valid. Affirming the consequent is not a valid form. That's where this one comes up. You can see the danger. Affirming the consequent creates the impression that the antecedent is true even when it isn't. So we've got tariffs now. Well, we don't anymore, but for a while we had these tariffs presumably to counter fentanyl. Might lead some to the conclusion that in fact that relationship was true. This is an affirming the consequent example, a logically invalid form. Denying the antecedent, also invalid for the same reason, because we already pointed out there are other reasons you could get an A. So does this seem straightforward to everyone? When you've got these conditional statements, you can either affirm the antecedent or deny the consequent. The other arrangements aren't valid because we don't have enough information. I've got a last example here, and then I think we actually are on track. And this brings about what's known as confirmation bias, which is kind of related to belief bias. But confirmation bias means that we tend to seek evidence that confirms. Belief bias is all about agreeing with conclusions we believe. Confirmation bias is even when you're seeking information, you tend to seek information that confirms. And you can see where the problem is already. If one of those logical forms is valid, affirming the antecedent, that's fine. That's good information for you because it helps you understand the relationship between A and B. But if the other kind of affirmation, affirming the consequent, is not valid, then it leads you to seek the wrong kind of information or information that doesn't help you determine whether or not a statement is true or not. You probably all know about the confirmation bias. How many of you are familiar with the idea of confirmation bias, right? It's kind of it's a standard way in which we believe, we understand how the world works. We do tend to seek out information that confirms. And that's the reason. It's very difficult. This goes back to a study that was published in the middle of the 20th century by P.C. Wason. It's now known as the Wason card selection task. But Wason was just interested in understanding why people who were adults at University College London, which is a great university, presumably well-educated people attending University College, appeared to be operating at a Piagetian level, suggesting they were still toddlers. He's like, why, when I give them this problem, are they unable to seek the right evidence? They are unable to do formal operational thought. How many of you are familiar with Piagetian stages? It's not something that you talk about in cognitive psychology, but you would talk about it in intro, you talk about it in development. And the idea is that once you become an adult, you can reason. That's essentially what we're talking about, is when you become a university-aged adult, when you're in your 20s, you should be able to conduct formal operational thought. And what Piaget meant is that you should be able to reason through different forms. That's what formal means. You should be able to apply mathematical thinking to solve problems and to come up with deductions. And what Wason was suggesting is that basically you can't. None of his participants were able to do it, and he couldn't figure out why. We'll talk about a simplified example, but let me just sort of give you the methods for his original study, because I don't know, I mean, like, this is not the kind of study most of us, we don't tend to read experiments and studies from the 1950s. So in the design, subjects carried out a selection task. They decided which of 4 cards, and he gives them letters here, P, P bar, Q, and Q bar, would enable them to determine, this is the important part I want to read, to determine whether a given conditional sentence was true or false. So your job is to have 4 pieces of evidence and then determine whether or not the conditional statement is a true one or a false one. Kind of just like the conditional statements we've been talking about. They were then invited to say what would render the sentence false. So they have to tell the experimenter, what do you need to show me that this is false? Tell me how to show that this is a false statement. Show me how to falsify this statement. Falsification is one of the hallmarks of scientific thinking, isn't it? You should construct experiments to falsify a theory. So that's what he's interested in. Can participants with a limited source of information, a very simple, constrained environment, correctly tell me how to falsify a statement? That's all I want to know. Are they thinking, can they think scientifically? And this is how he set the problem up. Here might be a statement. So I've got a series of cards that have numbers and letters on them. And we're understanding that there's something on the other side. They're two-sided cards. There's letters and numbers. And here's a statement. If a card has a vowel on one side, it's a card with a vowel, then it has an even number on the other. There's an example of an even number. So we've got an example of a vowel, a consonant, odd, and an even number. And what we want to know is if it has a vowel on one side and an even number on the other, what cards do you need to turn over in order to determine if this is true or false? In other words, how do you falsify this statement? How would you conduct an experiment to falsify this statement, assuming that if you cannot falsify the statement, it's true? What cards do you need to flip over and why?
A and 7, because A is a vowel, so if it doesn't even number, you're wrong. And then if 7 has a vowel on it, then it would also be wrong.
So A and 7 was your answer. A, which would affirm, that would look for affirmation of the antecedent, right? If A has an even number on the other, that's good. That aligns with the rule. If it has an odd number, or anything else for that matter, then this rule is not being followed. You've falsified the rule. And then you would want to turn over 7, because if there's a vowel on the other side, then it again suggests falsification of that rule. So you're looking to deny the consequence. That's the correct answer. What he found is that, and what most people would do in an experiment like this, is that they would tend to prefer, this is the confirmation bias answer, is that many participants would tend to choose things that confirmed. They correctly identify the A, which is affirming the antecedent, and then they look to confirm the consequent. They look for an even number, expecting there to be a vowel or a consonant on the other side. So if a card, most choose cards that confirm. This one is logically valid. This one is that invalid affirming the consequent form. So if a card has a vowel on one side, it has an even on the number, you're looking for this in order to confirm, and anything else is falsifying. You're looking for this to confirm. This is the 4 on the other side, and that's the E that you would flip it over to get. But what he pointed out, what Wason pointed out, which you could probably see, is that if you flip over, so you got the 4 on this side, you flip it over and you don't find a vowel, it doesn't mean that the rule has been disconfirmed. Because the rule is only about vowels on one side, even numbers on the other. It doesn't say that even numbers could also appear on the other side of consonant cards. If that's the case, the rule could still be followed. So this would not disconfirm. Does that make sense? So your answer was the correct answer. You look for one piece of information that confirms and another that tries to falsify. And what he was surprised by, and this is the A7 example that we should be turning over, this would prove it wrong. This would disconfirm. So what he was surprised by was that people couldn't do it. And there's a couple of explanations. One is that it asks you to prove a rule. And so we look for information that confirms. It also asks about vowels and even numbers. And so we naturally turn over a card with a vowel, turn over a card with an even number. There are also possibilities of attention and working memory considerations. So keeping these things straight. And that's the explanation that Wason kind of settled on, that this task is a little bit too complicated and too abstract for most people to be able to solve. There are too many different things to keep straight. He says, the selection task seems easy, but the selection which is resistant to therapy. When he says selection of P and Q, that's the answer that you chose. And he says it's resistant to therapy. He means that even when I tell people how to explain them how to do this task, they still can't do it. So he had some interventions where he tried to get people to reason correctly, and they were still struggling to do it. Through a long learning process to seek and expect a simple correspondence to hold between sentences and states of affairs. Now, we're reading something that was written in the 1950s. What he means is working memory limitations. You're keeping straight these different ideas. And when you've got several ideas to keep straight, we seek the simplest one. The simplest one is to look for information that can. He says the results are disquieting. If Piaget is right, then subjects in the present investigation should have reached the state of formal operations, but this is exactly what they singularly failed to do. So his University College London university students in the 1950s could not reach Piagetian adulthood with this task. And the reason seemed to be that there was too much to keep straight. It was too abstract of a task. An alternative version, and I've got two more examples left, and then 11:30 might be doable today, is a deontic selection task. A deontic selection task is easier for people. And the reason a deontic selection task is easier for people to solve is that it deals with permissions. Permissions are easier than facts because permissions mean that you don't have to do something. When you see a Wason card selection tasks, it's framed as statements of facts. And so you interpret it as a strict fact relationship, even numbers and vowels, right? That there's no other alternative. And you're not given the information about the other plausible configurations, that even numbers could appear on the back of every card. That's also allowed. We don't hear it that way because it's not presented that way. But when you're presented with something that activates what we call a permission schema, you're used to thinking about things that you may do but don't have to. Once you reach a certain age, you may drive a car, but you don't have to. Once you reach a certain age, you may drink alcohol legally, but you don't have to. You're just permitted to. This reduces the complexity of the task by activating a familiar reasoning schema, which could allow System 1 to operate. And so the alternative versions which have been explored are things like this. Suppose now in this deontic selection task, it has the same formal structure, the exact same formal structure as the Wason card selection task. But now it's been replaced by things that are meaningful and not just variables. Because you already know how some of these things work. We now have a person who we know to be 21 years old. We have a person we know to be drinking beer. We have a person we know to be drinking pop or soda, depending on where you live. And we have a person who is 17 years old. And you are now to determine, with the fewest number of card flips, is this rule being followed? A person is drinking alcohol, they must be over 19. It's deontic rather than absolute. They have to be over 19 to drink alcohol, but they don't have to drink alcohol. So it's the same relationship, but most individuals don't have difficulty pointing to this person. We just need to know how old this person is. And this person, we want to know what they're drinking. Pop drinker can be any age. I don't drink alcohol, so if I go to a bar, I'm going to drink a non-alcoholic beverage. The 21-year-old, it doesn't matter. They can drink alcohol or not, because that's not what we're concerned with. We're only concerned with whether or not this card and this card. So it's easier to seek the affirmatory evidence and the disconfirming evidence in a permission schema. May or must rather than true or false. And in fact, people are really flexible. We can flexibly adjust our permission schema depending on what perspective you're asked to take. Here are 4 different cases. You go to the superstore or the Loblaws or the No Frills, and sometimes they ask you if you want those, I don't know, what were those Marvel collectible, they're like stickers or something. And they ask me every time, do you want these stickers? And I'm like, do I look like I want stickers? Of course I don't want stickers. Do I look like I want any, or there's gifts. They'll say like, you spent $100, you can have these this package of President's Choice ribs or something, and you're given this option, right? That's a gift. That's a special gift. You spend a certain amount of money, you get a chance to take home President's Choice pre-made smoked ribs. So you've got two possible arrangements here. You can activate flexible schemas. Here's a person who spent $120, a person who spent $75, a person who received the free gift, and a person who did not take the free gift. Now, here's the rule you need to evaluate. If a customer spends more than $100, he or she may be offered the free gift, the free package of President's Choice brand smoked ribs. Which card do you need to flip over? Well, it depends on what your perspective is. People are really flexible and can answer the question correctly in most cases. Suppose you are the store detective. Your job is to make sure people are not getting the President's Choice ribs for free or taking advantage of the free offers. In other words, you care about this person, make sure they don't have the ribs, and this person, make sure they really did spend the right amount of money, right? You don't care with this person because this person maybe spent the right amount of money, but it doesn't matter if they took the gift or not. They're offered it. They're not required. This person did not take it. They could have spent $700 or they could have spent $50. It doesn't matter because they don't have the thing. Your job is only to look out for whether or not they took the gift. And if we ask participants in an experiment to take on the role or perspective of a consumer advocate, then they ask entirely two separate people. Now we just want to know, is the store keeping its promise? Did this person, were they offered the gift? And this person who did not take the gift, were they definitely spending under $100? Yeah.
How would you reword the first card selection task in this deontic?
Yeah.
I'm trying to just go back and think about that.
So which one, the vowel?
Letter one.
So how would we reword A and B vowel letter task to be deontic? Anyone want to take a stab at that? How might we reword that?
I guess like if we were to just use this example and were to assign like the A7 or D, it would be spent 120 because you're confirming that like they do receive the gift. So it's like confirming the antecedent.
Yeah.
And then the 7 would be did not take the gift because you're denying the consequent. You're making sure that if they did not take the gift, they were still made the offer. And then the E would be spent, sorry, no, now I'm confused.
That's okay. I am too. I am equally confused. That's all right. No, you're making good progress. What you're doing is you're mapping on what we did here in a deontic task with the A and B test. That's exactly how you would want to go with it. You had
We received the gift and the D would be spent 75, but I cannot explain to you how.
That's okay. No, you're on the right track. You've got your hand up.
I was thinking, the waste and card selection task, like going back on slide 86. Sorry, that's what I meant. How would we reword the rule-based?
How might we reword this one
Yeah.
to be deontic? So maybe you would say, if a card has a vowel on one side, it may have an even number on the other. Would that be a deontic task? Would that be easier? If a person is drinking vowels, no, if a person is over a vowel age, they may be drinking even numbers. Yeah, I think that works. Would that work? Okay. That would be a great question for an exam, is to ask you to reword one of these things, or to do what you did, which is to take the 121 and map it onto the AB exam and say, how would you turn this into a waste and card selection test? So we could do either one. I'm not promising that I'm going to have that answer or that question on the exam, but it would be a really good one. Does everybody agree with that? So we can turn a waste and card selection task into a deontic task by activating a permission schema. We can turn the permission task into a WASN task by structuring the question in a way that is not permission based, but rather is if you spent over $100, you must you must take a free gift. So you can make it more exclusive. That's a great question. Good job, both of you. Okay, so we got the last two slides. Deductive tasks. This is the take-home message. And we are finishing just about when I thought. See, when we don't take the break, we've got just the right amount of time to finish it. I really do need the break, and I don't really like to go this long breakless, but I felt like we were doing pretty good. Deductive tasks follow a strict logical form. We've seen that with all of the different structures we've had. That's the whole point of deductive logic, is that we try to strip away the knowledge. In fact, one of the reasons why a lot of logical forms are presented with A's and B's or P's and Q's is that we want to get rid of the meaning, because we can't help ourselves but to pay attention to the meaning. The whole point of using those formulas is if we want to determine whether or not the structure is valid, stop paying attention to everything else. Stop paying attention to the context. Don't worry about what Mrs. Shiver says. Just determine whether or not the structure is valid. And it can be fairly straightforward, but we have difficulty because it is cognitively demanding, and it's difficult to turn off your intuition. It's difficult to turn off your knowledge. And so logic is challenging for both of those reasons. We can do it, but it doesn't come easily to us. So all of the rest of our class, we're going to talk about decision-making and probability estimation. So I want you to keep in mind what we talked about today, which is for causal reasoning, we're undermined if we don't know the base rates. And for deductive reasoning, we're undermined because we can't avoid relying on heuristics like availability and representativeness. We make good decisions even though we don't tend to do them rationally all the time. Thankfully, most of our decisions are adaptive, even if they're not rational. Okay, if there are any foggy concepts, let me know either with this QR code or at some later time. 11:37, that's not bad. So remember, the quiz will be available at 12:30. If you were planning to come to office hours, it will be on Zoom only today, but that's usually still at 2 to 3. And midterm exam grades should be available later today on Brightspace. Have a good week, everyone.
Oh. Oh, bye, Shayla.
That's chair.
No worries. You're like